Hi everyone, and welcome back to Congruence and Similarity. Today is our final lesson on this unit of work, and we're looking at how to apply everything that we've learnt so far. So we're going to be looking at problems involving similar figures. Now the first question I want you to think about is, where might you see similar figures being used in real life? Okay, and I want you to think about that question, jot some things down, and we're going to start off with that as our discussion point tomorrow. Two really important things to remember that we've learnt so far. Equal angles are marked in the same way in diagrams. Okay, so if I've got two triangles, and they're no particular kind of triangle, but if I've got one curve here and one curve here, that means they're equal. If I've got two curves here and two curves here, then that means they're equal. Okay. Second thing, two triangles or figures are similar. Okay, so let's just change that to figures, because it can be any, it doesn't have to be a triangle, but two figures are similar if and we're not going to deal with this first one. Two figures are similar if matching sides are in the same ratio and matching angles are equal or the same. Okay, so keeping that in mind, let's have a look at these two problems. Here's the first one. Sam is 1.5 meters tall, and I'm going to highlight key things in this question, so you might want to do the same. And he casts a 3-meter shadow. At the same time, a tree shadow is 10 meters long. How high is the tree? Okay, so they want you to figure out how high, or this height here. So to me these look like similar triangles because they've told me this angle is the same as that. Okay, and it tells you in the question, it's got a bit of a hint there. Okay, now I want to find h, so I'm going to do and call upon what I did last lesson. So I'm going to go h over the matching side in this one, which is the height of Sam, 1.5, equals, sorry, I didn't mean for that line there to be on an angle, it should be a fraction bar. So h over 1.5 is equal to, go back to the triangle I started with, 10 over 3. Okay, and to get the height, I simply am going to times both sides by 1.5. So I'm going to do 10 over 3 times 1.5. And I have to use my calculator to do that. So getting my calculator out, I'm going to do 10 divided by 3, work out what that is, there it is, and times that by 1.5. And that tells me the height of the tree is 5 meters. And this is a word problem, so you can bet what I'm going to write next. Therefore, the height of the tree is 5 meters. Cool. Alright. So what do we do in that problem? Well, we highlighted the keywords, we read the question, and we decided what the question was asking us to do. And we had to understand the question before we knew where to go. We then used similar triangles and ratios of sides to figure out the height of the tree. Okay, let's have a look at this next question. It's a guy playing tennis. I love tennis. Great game. Alright, question 2. Find the value of the height in the following diagram at which the tennis ball must be hit so that it will just pass over the net and land 6 meters away from the base of the net. So here's the diagram given to us. Okay, let's have a look at it together. First thing I notice is that this is a similar figures problem, and in fact more specifically a similar triangles problem. Okay, so I am going to use my ratios again, just like in the previous question, and I'm going to go h over, so there's two triangles, there's this big one here and there's this little one here. So I'm going to go h over the little side here, 0.9, is the same as, now I started in the big triangle, so I'm going to start in the big triangle again, and that's going to be 12 plus 6 meters, which is 18 meters. Okay, and that's the whole length of the big triangle. So it's going to be 18 over the little triangle length, which is 6. And to get h, I'm going to need to times both sides by 0.9. Okay, so pulling out my calculator, I've got 18 divided by 6, and I know when I work that out, I'm going to get 3, and I'm going to times that by 0.9, and that gives me 2.7. Okay, so at this point, my height is 2.7 meters. Okay, and I can write therefore the height at which a tennis ball must be hit is 2.7 meters. Okay. Alright, what I want you to do now is to have a look at the website, to click on this link, and I want you to see if you can in fact do these questions. Okay, so when you click on it, it will take you to this site here, similar shapes. Tells you a bit about what we've been learning about so far, so you can have a quick read of that. And then it's got a lot of practice questions, so I want you to try them and then click show me to see if you get them right, and try some of these exercises, see how you go. Write down your answers in your book or on your sheet, and then write a summary of what you learned, any questions you had, and bring your booklet with you to class. So today what we've learned about is how to apply what we've learnt in similar figures to problems, and using ratios of sides to find missing letters again. Okay, so pause the video, write down the notes, write down or put a star next to anything you don't understand, and I'll see you in class tomorrow. See you later.